Hello everyone, thank you for joining us today. I am Mohammad Raihanul Bashar, a PhD student at the Exit Lab, Concordia University, under the supervision of Dr. Anil Ufuk Batmaz. Today I am presenting our research and early warning system based on visual feedback for light-based hand tracking failures in VR HMD. Virtual reality head-mounted displays create immersive experience by enabling users to interact with the virtual environment using controller, eye, bare hand, etc. And it enhances user presence and real-time engagement. These technologies are widely used in gaming, training, and industrial simulation. Recent advancements in vision-based hand tracking have made bare hand interactions more intuitive and natural while improving user engagement, presence, and task performance. However, tracking inconsistencies can break immersion, increase frustration, and add to cognitive workload. Modern VR devices that relies on vision-based hand tracking are highly sensitive to lighting condition, leading to inaccuracies that disrupt interaction and negatively impact the user experience. Barella Aldous reported that tracking inconsistencies break immersion and hinders user ability to interact effectively in virtual environment. Prior research found that visual feedback can improve task performance by providing real-time error correction. However, no studies have explored visual feedback's potential as an early warning system. What I mean is a proactive approach that alerts user before failure occurs, and this is where our research comes in. We address the gap by developing an early warning system that detects and visually signals potential light-based tracking failures before they impact the user experience. Our work is formulated based on two hypotheses. Hypothesis one, a visual feedback-based early warning system improves usability, and the second one is that it reduces cognitive workload when tracking failure occurs. To test this hypothesis, we conducted two controlled user studies simulating real-world hand interactions in VR. Before diving into our user studies, let's first look at how we designed the visual feedback system. To help users anticipate tracking failures, we implemented a visual feedback system using two floating spheres, one for each hand, positioned slightly above eye level. The color of this sphere represents the system's tracking confidence. Green means high confidence, meaning hand tracking is stable, and red means low confidence, warning users of an impending tracking failure. And those you can see from the top images. In the bottom left image, you can see how this feedback is integrated into an interactive task, and the bottom right image shows a participant interacting in VR while receiving real-time feedback. Let's move on to the user studies. In study 1, participant performed a pick and place task, stacking virtual cups in a pillar and a triangle shape. This was a within subject study with three conditions. Condition 1, no failing, means no tracking failures and no feedback. This is our base condition. Second one is with feedback, visual warning provided before tracking failures. And third one, without feedback, means tracking failure occurred but no warning was given. And tracking failures randomly occurs 3 times for both with and without feedback condition. We use the MetaQuest Pro as our VR HMD, and the virtual environment was developed in Unity using Oculus Unity SDK. We recruited 18 participants aged between 20 to 39 with varying levels of VR experience to ensure a diverse user base. To evaluate the effectiveness of our system, we collected task completion time, system usability scale, and NASA task load index data. These metrics provided both quantitative performance data and subjective user feedback, which allows us to assess the impact of early warning system on usability and workload. Now, this result. While task completion time remained consistent across conditions, usability and workload measures showed significant differences. In SOS scores, no failing and with feedback, both conditions received a C grade, while without feedback condition had the lowest score of 55, which falls into D grade, meaning poor usability. In NASA TLX, participants in the without feedback condition reported significantly higher frustration and cognitive workload compared to the other condition. Now, study 2. This study involved a ball sorting task where participants sorted yellow and blue balls into corresponding baskets. As with study 1, we tested the same three conditions with randomly induced hand tracking failures occurring 4 times during the task. This study introduced a more dynamic, goal-oriented interaction compared to the static carpet taking tasks. We recruited 18 new participants for this study, and other parameters remain same as study 1. So unlike study 1, task completion time was significantly affected here. Participant was slower in without feedback condition compared to other two conditions. That suggests that lack of feedback significantly slowed task performance. SUS and NASA TLX result reinforced our findings from study 1. The system usability scale scores reveal that both the no failing and with feedback condition maintain high usability ratings, whereas the without feedback condition saw a significant drop to 60.40 overall score, which is D grade, means poor usability. And that emphasizes the negative impact of missing visual feedback on user experience. And same as tax one, in without feedback condition, participant resulted in higher frustration and temporal demand as for NASA TLX that confirmed that unexpected failures means when no warning was provided about the tracking failure, it negatively impact performance and workload. Unlike systems that only respond to tracking failures after they occur, our early warning system allows users to anticipate and adapt before failures disrupt their interactions. This proactive approach helps reduce frustration and maintain immersion. Our findings show that task execution time varied significantly across the three conditions in goal-directed tasks. So the presence of feedback led to better user performance, confirming that early warning helped users adjust their actions more effectively. And in terms of usability, the ICS scores revealed a sharp decline in without feedback condition, as you can see from the graph over here, for in the both studies. Additionally, participants in the without feedback condition reported greater system inconsistency and lower confidence compared to the no failing condition. This highlights the critical role of feedback in enhancing user trust and system reliability, which align with our first hypothesis that an early warning system improves VR usability. Furthermore, the NASA TLX results showed that users experienced higher frustration and cognitive workload when feedback was absent. This support our second hypothesis, confirming that real-time warnings help reduce mental load by giving users time to react before a failure occurs. Overall, this finding emphasizes that predictive visual feedback is essential for improving VR interaction. In summary, we developed and evaluated an early warning visual feedback system for VR hand tracking failures. Our user studies demonstrated that providing real-time warnings significantly improves usability and reduces cognitive load. We believe that integrating preemptive feedback mechanism within the hand tracking system of HMDs can enhance the overall VR experience, user trust, and task efficiency across various applications. Moving forward, we aim to implement and evaluate our system with different VR HMDs. Also, we plan to explore alternative feedback modalities such as audio and haptic feedback. And that concludes my presentation. Thank you for your time.